All right, number 9, we're asked to solve this equation. The tough thing about this equation is that it's got a bunch of fractions in it. And we learned in earlier math classes, in earlier algebra classes, that the way to get rid of a fraction is to multiply by the denominator. Well, here we've got 3 different denominators. We've got p plus 1, p minus 1, and p squared minus 1. So what we're going to need to look for is the least common denominator. So we're going to need some expression that each of these denominators, p plus 1, p minus 1, and p squared minus 1, is going to divide evenly. So the first thing I want to do is notice that this p squared minus 1, that's a difference of squares. And so we can factor that pretty easily. And notice that this is going to factor to p plus 1 times p minus 1. So hopefully you can see here that the least common denominator is going to be p plus 1 times p minus 1. Because that is just this times this. So let's multiply the whole thing by p plus 1 times p minus 1. All right, so if we multiply this by the first term, notice that we've got a p plus 1 in the denominator here, and we'll get a p plus 1 in the numerator. So those will cancel out. They'll divide to 1. And what we're left with is 2p times p minus 1. And then the same thing happens here with the 3. When we multiply this by this, the p minus 1s will cancel out. They'll divide to 1. And we're left with 3 times p plus 1. And then on this last term here, both the p plus 1 and the p minus 1 are going to cancel out. We're going to be left with just 15 minus p. Now, this is a much easier problem. This is something that you would encounter in Algebra 1. Let's distribute that 2p. We get 2p times p is 2p squared. 2p times negative 1 is negative 2p. Distribute that 3 plus 3p plus 3 is equal to 15 minus p. Let's combine those like terms. That's 2p squared plus p plus 3 is equal to 15 minus p. Now we've got a quadratic expression here. So the easiest way to solve this is going to be to get this equal to 0, to move everything over to one side of the equation, set it equal to 0. So let's add p to both sides, and let's subtract 15 from both sides. So we get 2p squared plus 2p minus 12 is equal to 0. Now we can factor this. Actually, first we've got each of these terms is divisible by 2, so let's factor out a 2. We get 2 times p squared plus p minus 6. And then we can actually get rid of that 2 altogether by dividing both sides by 2. So if we divide this by 2, the 2 goes away. Divide 0 by 2, we get 0. So we're just left with p squared plus p minus 6. Let's factor that. We need 2 numbers that multiply to negative 6 and add to positive 1. So that's going to be 3 and negative 2. So we've got p plus 3 times p minus 2 is equal to 0. So p is equal to, if p plus 3 is equal to 0, p is equal to negative 3. And if p minus 2 is equal to 0, then p is equal to 2. So those are our 2 solutions. With rational functions, you always want to make sure that your solutions don't cause one of our denominators to equal 0. We don't want We don't want these solutions to, if we plugged them back in, to give us something that's undefined. So we got to check those solutions. -3, that's not going to make that 0, not that, not that. And same with 2. So those are both, these are both good solutions. And that's going to be our answer. P equals -3 or 2.